Okay, we're going to continue our look at transformations by considering vertical stretches next. Again, we start from the same parent function, y is equal to f of x as defined by this graph, and we've got this table of values to show us the key points, also shown in red. And the question says, given y is equal to f of x, graph y is equal to 2f of x. So we've got a 2 multiplied out front here in front of the f of x. So if we were to fill in a new table of values, the x values are going to stay the same, but the y values are equal to 2 times f of x. Well, for each x value, we can look up its corresponding f of x value in the table above. So when x is negative 4, f of x is 0. That means that 2f of x is 2 times 0. We just plug in f of x here in where it says f of x here. So 2 times 0 is still 0, so that one hasn't changed. But if we plug in f of x that corresponds to x of negative 2 from above, we plug in negative 4, now the new value is negative 8. So when we're graphing y is equal to 2f of x, this point is no longer going to be negative 2, negative 4, it's going to be negative 2, negative 8. For 0, we get 2 times the f of x value was also 0, so that's not going to change. For 2, the point 2, 2, we multiply the y value of 2 by 2 and we get 4. And for 4, 0, we multiply the y value by 2 and we get 0, no change. So notice that these points here, all the points that had 0 as their y values, are not changing at all. Their y values are not changing. They're going to stay on the x-axis. Whereas the other points, which are off of the x-axis, are having their y values doubled, but the ones on the x-axis, doubling 0 is still 0. So this graph is now going to look like this. And what that is a vertical stretch. It's a vertical stretch of factor 2. In other words, all of the y values are being multiplied by 2. It's a vertical stretch of factor 2. We're stretching everything twice, or two times as far away from the x-axis. Let's take a look at another example. Now if we had y is equal to a half of x, a half f of x, it means we're taking all of these f of x values and halving them. So half of 0 is 0, half of negative 4 is negative 2, half of 0 is still 0, half of 2 is 1, half of 0 is 0. So again, if we were to plot negative 4, 0, it's there. This middle one, 0, 0, is still here, 4, 0 is still there. Those haven't changed, but the point 2, 2 has now become the point 2, 1, and the point negative 2, negative 4 has become negative 2, negative 2. So now we have this graph, and it's been squished or compressed in towards the x-axis. So this is a vertical stretch factor a half. Now sometimes you'll hear this called a vertical compression of factor a half, and different teachers will prefer different things. I'm going to call it a vertical stretch factor half, although you might hear a vertical compression factor half as well. So the x values have stayed the same, and excuse the difficulty I have drawing on this and the not so straight lines. But you get the idea that it's been, all the points off of the x-axis have been pushed half the distance towards the x-axis. So vertical stretches occur when you have a coefficient out in front of the f multiplied by f of x, and it's going to stretch the graph vertically by whatever that factor is. So if this was a 2 down here, it's going to stretch it by all the y values by a factor of 2. If it was 0.25, they would all get squished down towards the x-axis, squished to a quarter of their previous values. So vertical stretches occur when you have a number out in front of the whole function, and that number is going to be multiplied by all of the y values, stretching it or squishing it. Next, we're going to look at vertical reflections.